Okay, we're going to carry on looking at areas under curves and integration, but they're going to get a bit tougher. Okay, the reason this one's harder is because you're finding the area between two things. We've got a line and a curve, and we're trying to find the area between them. So if there are two things, I'm going to show you a little series of steps. The first thing you do is you find out where the two things cross. The second thing you do is you drop the parachute. That will become clear later. The third thing you do is you integrate something, usually the curve, not always, but usually the curve between the limits that you've just found. Not always though, but usually. And the fourth thing you do is you think about some shapes. All right, so that's your little kind of, that's your little list. Okay, so let's start. The first thing we're going to do is we're going to find out where they cross. Okay, so that's just simultaneous equations. X squared minus 2x plus 3 equals 9 minus x. X squared, let's move him over and let's move him over, becomes minus x minus 6 equals 0. And therefore we're getting x minus 3 and an x plus 2. And therefore they're crossing at 3 or minus 2. Okay, now that means that point there and that point there. Right, that's the first bit, that's the cross. The second thing we're going to do is we're going to drop this parachute. All right, this is the most important bit. Here he comes. My parachute man. There he is. Parachute man. Okay, we're going to drop that parachute, which means we're going to drop a line down here. And this is, of course, minus 2, and this is x is 3. Okay, so we've crossed, we've dropped the parachute. The third thing we're going to do is we're going to integrate something. Now, usually it's the curve, all right? Not always, but usually. So x, oops, rub that out, x minus 2x plus 3. And we're usually going to integrate the curve between the limits that we've just found. So that limit is the highest, that's on the right, that goes on the top. And this limit is going here on the bottom. All right, and the reason that we do that is because we want to show the examiner that we know to find the area underneath the curve, we integrate y, the curve, with respect to x. Okay, so let's have a bit of a think what happens when we're actually going to do that. So what we're going to find is we're going to find the area between the curve, if we integrate the curve, the limits, so x is minus 2, x is 3, and the x-axis. So we're actually going to find this area here. Now I know it's not the area we want, but we'll come back to that later. Okay, so let's start by doing my integration. All right, I'm going to set it up so I can integrate. So big square dog, and it's going 1 bracket bracket x minus 2 bracket bracket x plus 3 bracket bracket x. Okay, add 1 to the power gives me 3, and to flip it, add 1 to the power gives me 2, and flip it. Add 1 to the power gives me 1, and flip it. Okay, and my limits, 3 and minus 2. Okay, so let's neaten this up. We've got a third x cubed minus, those will cancel to give me x squared plus 3x to the 1, and my limits are 3 and minus 2. Okay, so now I'm going to feed in my 3. So I'm going to get a third 3 cubed minus 3 squared. Notice all the brackets I'm shoving in, 3. All right, there's my big bracket. And then we're going to put the minus 2 in. A third minus 2 cubed minus, be careful of this one, it's minus 2 squared plus 3 times minus 2 into the big bracket, and we are subtracting them. Okay, 3 to the power of 3 is 27, divided by 3 is 9. 3 squared is 9, there's a minus, plus 3 is 9. So that's the first bracket. Minus 2 cubed is minus 8, so minus 8 over 3. Now be careful here, it's minus 2 squared, which is 4, positive 4, but there's this minus here. So it's minus 4, and then here it will be minus 6. Okay, so 9 minus 9 plus 9 will give me 9. That's the first bracket. And if I do minus 8 over 3 minus 4 minus 6, I'm going to do that straight on my calculator. I'm going to get minus 38 over 3. And 9 minus minus will give me, these will give me a plus. And I should end up with 65 over 3. All right, 65 over 3. Okay. So the area of this red section here is 65 over 3. Okay, so we have found the area of the red section, that's 65 over 3, but that's not the area we want. So the last bit on my list was to look at shapes. Now I'll look at this shape I'm pulling out now. Can you see it's a trapezium? So if I could find the area of that trapezium, then I could take away my red area, there's my red area, and I will be left with a little region that I want. So we're going to concentrate on finding the area of this trapezium. Now, the formula for a trapezium is this. It's basically AB, those are the two parallel sides. So you add the two parallel sides together. The h is strangely the height, well, it's actually the width between them, and it's h over 2, a plus b. So in order to find this side, let's try and find this height. This height, you can feed it into either this one or this one. I think this one is going to be easier, isn't it? So when x is minus 2, the height is 9 minus 2, which must mean it's 11. And if we do this one, when x is 3, the height is 9 minus 3, which must mean it's 6. And so that one's 6, that was 11. And the height between them, or the width between them, is 5. So let's feed that in. We're going to get 5 over 2, 11 plus 6, and 5 over 2 times 17 gives me 5 over 2 times 17 gives me 85 over 2. So I reckon that my lovely trapezium has got an area of 85 over 2. Okay, so we're going to finish off. How do we find the area of R? The area of R is the area of the trapezium minus the area under the curve. So the area of the trapezium is 85 over 2. The area under the curve is 65 over 3. And I'm going to put that all into my calculator. And my calculator tells me 125 over 6. Okay, why don't you try this one? Pause the video and see if you can get this one to work. And I'll go through the answers. Okay, here are the answers. So first thing we're going to do is find out where they cross. So that's just a nice little easy simultaneous equation. I'm going to move everything over to the other side. I'm going to get x squared, 2x minus 6x is minus 4x. Factorise out my x, and I'm going to get they're crossing at 0 or 4. Okay, let's move that over. They're crossing at 0 or 4. So we're going to drop the parachute at 0, and we're going to drop the parachute at 4. Sorry, gang, I can't love this, my little parachute. There he is, always having a bit of trouble. There he is. All right, so we're going to drop that parachute. Right, okay, so next thing we're going to do is we're going to integrate something. We're going to integrate usually the curve. So let's see what happens when I integrate the curve. And I'm going to try and see what happens when I integrate between the limits I've just found. Okay, so let's have a bit of a think what area that would give us. So it would give us the area between the curve, there's my curve, the limit 4, the limit 0, it would give me this area here, wouldn't it, in red. All right, it's not exactly the area I want, but I'm going to keep going and see what happens. So arrow, arrow, there's a 1 in there, big square dog, 6 bracket bracket x minus 1 bracket bracket x square dog. So we're going to add 1 to the power here, gives us 2, and flip it. Add 1 to the power gives us 3 and flip it, and my 4 and my 0 are coming across here. Okay, so let's neaten that up. 6 halves are obviously 3, so 3x squared minus a third x cubed in 4 and 0. So the 4's can go in, 4 squared minus a third, 4 cubed, and then the 0's can go in, 0 squared minus a third, 0 cubed, big bracket and a minus in the middle. Okay, 4 squared is 16 and 16 times 3 is 68. 4 cubed is 64, so that's 64 over 3. Minus, oh, I love these ones because this whole thing's 0, isn't it? So, okay, 68 minus 64 over 3, that whole thing, I'm just going to bring it straight in my calculator. 80 over 3 minus nothing, so that area is 80 over 3. Okay, so my red area sort of kind of like a shape like that, isn't it? Is coming to 80 over 3. Right, now I'm going to look at my shape. That's not the area I want, is it? What I want to basically do is in here, if you look at the green, I've got a triangle here. Right, there's my green triangle. And if I can subtract that green triangle, I can find my grey area. Okay, well that's nice and easy because that's 0 and that's 4, so that must be 4. And now I want to know this height here. Okay, so all I've got is, I've got when x is 4, I can substitute it into here or I can substitute it into here. That's going to be easier, isn't it? So when x is 4, my height is going to be 2 lots of 4, so it's going to be 8. So this is up here, this is 8. Okay, so 4 across and 8 along. So the area of the triangle is a half base times height, so it's a half times 4 times 8, so I reckon it's 16. Okay, let's put it all together. The area of R is the area of the red section, which is that section there, which is 80 over 3, minus the area of the green triangle. There's my green triangle, which is 16. Okay, so let's come down here. 80 over 3 minus 16 gives me a final answer on my calculator of 32 over 3. Did you get that?